When humanity launched the James Webb Space Telescope in late 2021, scientists expected a revolutionary machine. What they did not expect was a telescope that might challenge the foundations of modern cosmology itself. Webb was designed to look farther into space than any instrument before it. But looking farther into space also means looking farther back in time. Because light travels at a finite speed, every distant galaxy appears not as it is today, but as it existed billions of years ago. In a sense, Webb is a time machine. It captures ancient light that began its journey long before Earth even existed. And almost immediately after beginning operations, the telescope started revealing something deeply unexpected. The early universe did not look young. According to the standard cosmological model, the first galaxies should have been small, chaotic, and primitive. After the Big Bang, matter was expected to slowly gather under gravity over immense stretches of time. Tiny structures would merge into larger ones. Stars would gradually ignite. Galaxies would slowly evolve into the organized spirals and giant ellipticals we observe today. That was the expectation. But Webb's observations complicated that picture almost instantly. Some of the most distant galaxies ever detected appear astonishingly massive and surprisingly organized, despite existing only a few 100 million years after the Big Bang. Instead of looking like cosmic infants, they resemble mature galactic systems already filled with enormous populations of stars. It is as though the universe evolved far faster than physics currently predicts. And scientists are struggling to explain why. Some astronomers suggest that the early cosmos may have experienced intense bursts of star formation, allowing galaxies to grow at extraordinary speeds. Others suspect hidden observational biases or uncertainties in the data. But even with caution, the tension remains impossible to ignore. The early universe no longer appears simple. And galaxies are only part of the mystery. Webb has also revealed evidence suggesting that supermassive black holes formed astonishingly early in cosmic history. Under conventional models, black holes should require long periods of growth through mergers and accretion. Yet Webb is detecting giant black holes that appear to have reached enormous sizes far too quickly. Some researchers now propose that certain black holes may have formed through direct collapse, enormous gas clouds collapsing instantly into black holes without first becoming stars. If true, that would force major revisions to current theories of cosmic evolution. Then there are the strange theoretical ideas returning to scientific discussion. One of the most fascinating is the possibility of dark stars. Unlike ordinary stars powered by nuclear fusion, dark stars would theoretically generate energy through interactions involving dark matter, the invisible substance believed to make up most of the universe's mass. If such objects existed, they could grow incredibly massive while remaining stable for long periods of time. And they might help explain why massive galaxies and black holes appeared so early after the Big Bang. Dark stars remain entirely hypothetical. But the fact that scientists are reconsidering ideas this speculative reveals how disruptive Webb's discoveries have become. Because when observations refuse to fit established theories, science is forced to adapt. And Webb is doing more than refining old models. It is exposing the limits of what humanity currently understands about the universe. For decades, cosmology appeared increasingly precise. Scientists believed they were approaching a complete picture of cosmic history. But now, every new Webb observation seems to raise even deeper questions. How did structure emerge so quickly? Why do early galaxies appear so mature? How did black holes grow so massive so early? And most importantly, what else about the universe are we fundamentally misunderstanding? Because the deeper Webb looks into the cosmos, the stranger reality becomes. While Webb is transforming cosmology, It is also revolutionizing humanity's understanding of planets, stars, and the origins of life itself. One of the telescope's most powerful abilities is infrared spectroscopy. By analyzing starlight passing through distant planetary atmospheres, Webb can identify chemical signatures across unimaginable distances. And the results have been extraordinary. Some exoplanets appear wrapped in thick atmospheres containing water vapor, methane, carbon dioxide, and complex chemical interactions unlike anything previously expected. These worlds reveal that planetary systems may be far more diverse than scientists once imagined. Among the most intriguing discoveries are potential ocean worlds, planets that may be covered almost entirely by deep global oceans beneath dense atmospheres. One example is GJ1214b, located roughly 40 light-years from Earth. For years, astronomers struggled to study it because thick haze obscured its atmosphere. But Webb's infrared instruments have started penetrating that veil, revealing clues about what may lie beneath. Conditions there are likely extreme, with crushing pressure and intense heat. Yet discoveries like this suggest ocean-covered planets may be surprisingly common throughout the galaxy. And if water-rich worlds are widespread, then environments suitable for complex chemistry, perhaps even life, may be far more abundant than humanity once believed. Closer to home, Webb is also transforming our understanding of how stars are born. Unlike visible light telescopes, Webb can see through dense clouds of cosmic dust using infrared light. Regions once appearing dark and empty are now revealed as violent stellar nurseries where entirely new stars are forming in real time. Inside these enormous clouds, gravity slowly pulls gas and dust together until temperature and pressure rise high enough to ignite nuclear fusion. What Webb sees inside these regions is not calm or static. It is chaotic. Jets of gas erupt outward from newborn stars. Shock waves tear through surrounding material. Entire planetary systems are beginning to take shape. And Webb has also captured dying stars in astonishing detail. As stars exhaust their fuel, many begin shedding their outer layers into space, forming glowing structures called planetary nebulae. These spectacular clouds are not merely beautiful. They are essential to cosmic evolution itself. Inside stars, heavier elements are forged through nuclear fusion. Carbon, oxygen, silicon, iron. The elements that make up planets, oceans, and living organisms were all created inside ancient stars long before Earth existed. When stars die, those elements are scattered back into space, becoming the raw material for future stars, future planets, and eventually life. In a very real sense, Webb is helping humanity trace its own origins. Every observation reveals another chapter in the story of how matter evolved across cosmic history. But perhaps Webb's greatest achievement is not simply the answers it provides. It is the uncertainty it creates. Throughout history, major scientific revolutions often began with observations that did not fit accepted theories. The motions of planets challenged ancient astronomy. Quantum physics shattered classical certainty. Relativity transformed humanity's understanding of space and time. And now Webb may represent another turning point. Because the more clearly humanity sees the universe, the more mysterious it becomes. Ancient civilizations looked at the night sky and imagined myths and gods. Modern science replaced mythology with mathematics and telescopes. Yet standing at the edge of this new observational era, humanity is discovering something extraordinary. Reality may be far richer, stranger, and more complex than even our most advanced theories anticipated. Every distant galaxy captured by Webb carries light older than Earth itself. Every planetary atmosphere hints at environments unlike anything in our solar system. Every unexpected discovery forces humanity to reconsider what it thought it understood about existence. And perhaps that is Webb's true legacy. Not that it solved the mysteries of the cosmos, but that it revealed how many mysteries still remain.